Hey everyone, my name's Jeff, and I've been finding the best ways to create fast and maintainable Dapper repositories. To demonstrate how, I'm refactoring a typical repository that returns 20 customer aggregates along with their order information. Now below are the 3 key metrics I'm going to improve upon using the techniques I've talked about in previous videos along with grid readers. You'll see how I reduce the amount of data transferred from the database by 48%, memory allocations down by 80%, and the time it takes to return those customer aggregates down by 99%. All right, let's give it a go. So what's typical about this repository? Well, it takes an iterative approach to populating an object graph. There's a function that gets all of the customers based off of a filtering criteria, for example, a name. And then for each level in that object graph, it executes a query to pull back all of the children for that node in the graph. So here you can see we get all of the customers, and then for each of those customers, in this case there's 20 customers, so we're going to run this query 20 times to get all of the orders for each customer. And then we need to get all of the order items. So there are 30 orders for each customer, so we need to get all the order items. So we're going to end up for a single customer pulling back 32 result sets from the database to populate one customer aggregate. Now, this design negatively impacts all 3 of our metrics. And from a network perspective, we have to send 32 requests and responses to SQL Server. And there is communication overhead there that we're doing. So we're moving more data over the wire than we really need to. From a memory perspective, I'm creating lots of connections and executing lots of queries. So there's more memory allocations needed to complete that work. From a time perspective, out-of-process calls take a long time, so making unnecessary calls really influences the amount of time it takes to complete this repository task. Also, we're issuing many calls to SQL and making SQL execute that same filtering criteria every time. So it's taking SQL longer to do this work because of this iterative pattern. Well, let's refactor this repository and start by fixing the biggest problem first, reducing the number of queries needed to populate the aggregate. One query. I've talked about this in another video, so I'll keep it brief, but I want to have one query that returns all the information I need to populate the aggregate. And I want to separate the filtering logic from it. The way I'm going to do this is by using a table variable. Filters populate the table variable, and the query uses the table variable to decide which customers to return by including it in the where clause. All right, now let's look at how to execute the query. The get function is a private function that's called by each of the filter functions. It gets fed the filter query string along with some parameters needed to execute the filter. And rather than make one query for each level of the aggregate, I'm employing Dapper's grid reader. When it's executed, it will return multiple result sets for each level of the aggregate with one call to the database. So it's important to remember that you have to read each result set in the same order as the query provides them. So when we look at the query, you can see that I get the customers first, so I need to read the customers first. Orders work the same way. Order items are actually a little bit different. You see, in the database, an order item has a column that stores the product ID. So let's look at the domain class for order items. I have a product representing the product that's being purchased. Dapper's not going to know how to map a product ID to a product object, so I need to have a way to match up an integer from the database to a product object in the aggregate. And to do this, I'm going to use a feature in Dapper called multi-mapping. It allows you to map a single row to multiple objects. We can use the parameter split on to specify when one object ends and the next one begins. All we need to do is provide Dapper with the column name that denotes where that split should begin. The read operation splits the row into an order item object O and a product P. Then we just need to use reflection to set up the order item's product property with the actual product object. Then we need to match up those order items with their correct orders and the orders with their correct customer. So that should take care of populating the aggregates. Before we talk about running benchmarks, I think it's important to discuss how the shape of data affects performance. And I've assigned 3 different shapes to describe the data in the customer aggregates. The first one is the bar shape. It has one customer with one order per customer and one order item per order. So the object graph is tall and narrow, resembling a bar. And the second one is the triangle. It has one customer, 5 orders per customer, and 30 order items per order. So there's a whole lot more nodes at the grandchild level than there are at the parent level. And the last one is the diamond, where we have one customer, 30 orders per customer, and 5 order items per order. So in that case, we have a lot fewer grandchild nodes than we do parent nodes. Now, when we run these benchmarks, I want to show you what the impact of those shapes that they have on the 3 metrics of data that are received: memory allocated and execution time. So let's go ahead and get benchmark.net running, and let's take a look at the results. Here's the results from our performance test. I've got the performance metrics of execution time, memory allocated, and data received across the x-axis. And I've actually broken it up into 3 chunks to represent the shape of the aggregates. So I think there's 2 major points that I see when I look at this data. And the first is that making a single call to the database is a significant performance improvement in all of the metrics, especially in execution time, but across the board. You just can't beat that. You're just doing less work. And so that's always going to be your best option. The second point I think is a little more subtle, and that's that using grid readers instead of an iterative approach means that you're going to have more consistent workloads despite changes in the shape of that data that you are querying. And so I think the place where this pays off is where you're writing a new application. You don't have a bunch of existing data to back it up. And so you aren't necessarily going to know what that performance is going to look like. And if you're using grid readers, you're making one call to the database. It's just not going to fluctuate as that data grows and changes. So I think that's kind of a nice thing about this approach. I do think that there is still room for improvement on this. I think we could squeeze a little more performance out of it if we wanted to, but I'll save that for another day. If you have suggestions, please leave a comment down below. And always, please subscribe, and I'll continue to put out some content that I hope everyone finds useful. And so have a great day. Thanks for listening.